Good morning to all. Myself, Dr. Arun Negemia from Aerospace Engineering Department. Today, I am going to take one topic from Aerospace Propulsion subject. So, if the topic name is Factor Efficiency in Aircraft Propulsions. So, in that, the why efficiency matters. So, it says in the aerospace propulsion. So first one is the economic impact. So the total economic impact it will be happened in the fuels. So the mostly the 30 to 40 percentage of airline operating cost it can be taken by the fuel only. Next one is the environmental responsibility. So in that things the globally the 2 to 3% of CO2 it will be emitted from the aircraft, and next one is the performance advantages. So in that cases the enable the longer range, higher payload capacity, reduce noise pollution. So these are all things it can be reduce the pollutions. Next one is defining the efficiency in the aircraft propulsion. So first one is the thermal efficiency. So in that thermal efficiency, the here the chemical energy converted into mechanical energy. So the in that part it will be run and with the help of the engines only. Next one is limited by the Brayton cycle in that thermodynamics part, and next one is propulsive efficiency. So here the propulsive efficiency it can be calculated by the ratio of thrust power to the total airflow power, and overall efficiency it can be calculated by the product of thermal into propulsive efficiency. And the next one is the propulsive efficiency it can be defined by the neta into P. Neta the that is called as a efficiency of the propulsion, and P it is a power. So in that efficiency it can be calculated by the thrust into flow flight speed, and power it can be calculated by the thrust into jet velocity. By using these cases, so we will check the uh, efficiency and the velocity during these cases, and by applying the real world performance. So in that turbojet engines it can be achieve the 30 to 40 percentage of efficiency, and turbofan and turbo prop it can be achieved 70 to 80 percentage of efficiency. Next one is identifying losses in propulsion system. So in that cases, the first one is a thermal loss. So in that due to the thermal loss, the turbine it can be heated during the flying conditions due to the incomplete combustion. Next one is mechanical loss. So in that mechanical loss, the bearing gear boxes are wear due to the friction. Next one is aerodynamic losses. So in that cases, the flow separations and the shock wave formation, turbulence formations, it can be damage the compressor and turbines. And next one is excess kinetic energy. So due to these cases, the more amount of kinetic energy formed, so results it can be reduce the formation of thrust. Next one is the by visual losses in jet velocity and flight speed. So in that visual losses, the by using the modern turbofan, so we will get the 85 percentage of high bypass ratio compared to the turbojet. So in that turbojet, it have only 35 percentage. And the next one is the case study of fuel economy improvement in modern turbofans. So first one is the engine. So in that new modern turbofans, they have used for the Boeing 777X type engines. So in that engines, it can be used the 10% better fuel efficiency compared to the previous engines, and by using these cases the 200 million gallons fuel burns it can be reduced. And next one is the key innovations. So in that key innovations, the composite fan blades has been used for these cases, and the high bypass ratio, it can be improve the thrust efficiency, and emerging technology to boost efficiency. Here there are the three criteria. One is called as hybrid electric propulsion. So here the NASA can be try to implement the turbo electric systems. It can be reduce the fuel burn up to 10%. And next one is the boundary layer integration. So in the boundary layer in insertion, it can be reduce the interact between the two boundary layers. And last one is the advanced material usage. So here they have used for the high temperature material, ceramic, metal matrix materials. These are like materials. It can be used to formation of overheat in the turbine sections. So thank you. So we will catch you on next topic on next video.